Yo, how's it going, folks? It's me again, your boy Tabo, and this is another lesson on SVG for the web. And so today we're going to be discussing more on filters, and today's topic is going to be on specular lighting filter. Okay, so let's jump right into it. So I'm going to create my devs tag. Say devs. Okay, in here I'll be defining my filter. So I'll say filter, and I'll give it an ID of, I'll say specular. Okay, then inside, then I'm gonna create my FE specular lighting filter. Okay, so my specular lighting filter has a value of n. An attribute of n. So we're gonna say source alpha, and then another is we've got a specular exponent. Okay, so I'm gonna give it a value of I'll say 20, and then we've got a specular constant. Okay, and then the specular constant will be, I'll say 0.75. okay, and then lastly we're gonna add a result, and so the result will be speculight. Okay, so we're going to call our result speculight. Okay, so inside here we're going to use a point light, so we're going to say FE point light. Now point light has an X attribute, so we'll say 600, and then Y we'll make it 50, and then we'll say I'll give it a Z value of Z value of 200. Okay, so now what we're gonna do next is then we're gonna composite all of this. So what I'll do is I'll say FE composite. I'll say N equals, I'll use the source graphic, and then I'll say N2, then we'll use a spec light. Say spec light. Okay, N2. And one thing that I noticed my previous tutorial, I actually forgot to name this N2, but I also noticed that it actually didn't make any difference. I tried to see if I changed it to 2 if it would make any changes, if it does anything, but it doesn't. So I'm assuming that somehow it manages to kind of make sense of the sequence, that if I start declaring this one first, then this one automatically is attributed to N2, even though I might not specify here. But at the moment it's just an assumption, but what I noticed is that it didn't make any difference. Actually, the results are still the same, so nothing was changed. But I think, well, for safety's sake, it's better to call it N2 because this is standard. Also, if what you're doing is professional and somebody else is going to be maybe working on your code, or just, yeah, to avoid confusion. Okay, so I'm going to use an operator, and I'm going to use arithmetic, and okay, I'll say K1 is equal to 0, and I'll say K2 is equal to 1, and I'll say K3 is equal to 1, and I'll say K4 4 is equal to 0. Okay, so that's that for my composite. Okay, so that's that, and then what I'm gonna do now, I'm gonna create a rect. Okay, and give this rect of x value of 600, and I'll say y is equal to 50, and then I'll give it a width of 200, and I'll give it a height also of 200, and then I'll give it a fill, a color of blue, and then I'll say filter is equals to URL, and then I will then assign it specular. Okay, so everything should be in order. So now I'm gonna then open this up in our favorite browser and let's see what that looks like. Okay, nothing to be seen. Okay, there we go. Okay, that was my mistake. Okay, so this is what it looks like. Okay, this is our graphic over here. So what I'm gonna do is basically, I mean, if I change this to that, basically this is what we get. Now this is what I realized, that this is what it would look like. Basically, because the shape is blue, then this is the part where the light is hitting. So it's lit blue, and then the rest of it is white, which would be kind of a contrast to what one would get usually if I was using diffuse lighting. Then yes, this part would be blue, and then this would be darker. Okay, so using these values, this is the result that one would get. Okay, so this is what we get now. So since this is the part that highlights the color, or maybe the light where the specular would be hitting, but then the specular would need to be white, right? If you want to show a specular color, usually spec is white, or unless if the light has a different color, then the specular would be that color, the color of whatever the light source is. Okay, so when you change these values around, this is what you get. So now if I make that 0 and make that into 1, this is what we get. Okay, so now this whole thing is blue. So meaning that this, it will go from white to blue. Okay, so that is quite clear that that's what that will do. At the moment it's white, that's why you can't see anything. And then this part, this is just where the light is hitting. So now the color is blue, and then the rest is fading to white. But this is, so this value is indicating where the light is hitting. And that's what I've kind of gathered from all of this. So now we turn that into, we change that around, because we don't just want to see where the light is hitting, but we want to get other values, which we're going to use these values. Now, to be honest, I mean, when I look at the documentation and all of that, it's not really clear exactly what they mean. So I'm just I'm putting it together as I go, you know. So this is just from my own kind of observation and common sense. So this is currently blue, and so what this does, it's kind of similar to this value, right? So this would indicate where the light is hitting, but it would invert it instead. So at the moment it's blue, okay? When it's at 0, then from my observation, the assumption is that it's blue. So when it's 0, then at the moment this is all you will get. So everything is blue, okay? So even where the light is hitting, even this is blue. So rather, when you then invert this, because also this is not turned on, so it is not actually being reflected. So basically what's happening is that these values have been inverted. When this is 1 and that is 0, then the part where the light hits is blue, and then because everything else is kind of white, it is only exposed by this. So now this is not exposing anything, but this is not hiding anything either. So when you use this value, when you turn it to 1, so that is kind of that value, but it's now inverted. Okay, it's because that is blue, that should be now white. So basically now you get to see this part, which is the part that is being lit. So this is so far what I've gathered from everything that I've done. And so as usual, we can always include change the size. So at the moment it's at 0.75. Okay, let's see what the specular exponent does so that we can also kind of get an idea. So basically this is kind of spreading the light source. It looks like some sort of spreading of the light, and then the higher it goes, then the more sharp it gets, but small. Then the light is concentrated in one area, but it gets smaller. So we'll make it 100, and this is what we get. So that's that. And if I then move the light also more, I'll say, let's say 650, and then I'll move it also 50 units here, so we'll make it 100. Okay, so now you see this light more and how it is concentrated. I can increase that size there, and you can see that becomes a lot more intense. You can see the specular shape becomes a lot bigger and it covers more of the shape. But I'm going to turn it back to 0.75, and we'll just basically work with this. So the specular exponent, I'll make it 500. Let's see what that does. So once again, it's small again. Yes, I also left out one other value, and that is the surface scale. Now the surface scale is basically how high the surface of my shape is. So if I say 2.5, that would also be influenced by this. So if it's 2.5, when I then make it, I'll just make it 5. Then see, now it's like a little speck there, almost invisible. So I will make it 50, and then that's what it is right there. And I will bring I'm gonna turn that, make that 1. So now it's spreading, so I'll make that let's say 1000. Okay, so that's what you get there. So you can play around with these values and see what kind of effects you can get. If I say the surface scale is 0, then let's see what that looks like. So the closer I am to the surface, then the more, see, that's what I get. I mean, I can make constant a lot bigger, so I'll just say 10. Okay, so that's what you will get, but it's now a lot more focused and intense. It's almost like if you think of light, if you concentrate it, then it becomes almost laser-like. Say constant. So this is pretty much what you get. Okay, that didn't make any changes. Let's see, 50. Okay, there we go. These are the different effects that you can get. So I'm gonna turn it back to 20, and then I will make the constant. Okay, so yeah, this is what you can get, just the different kind of values that you can get by playing around with this. So I'm just gonna then bring it out more. I'll say 100, and then you see, then I'll take it back to 600, and then I'll also say 50. Okay, so yeah, there it is. So this is pretty much how that would look. I'll say this constant, make it 1. Yes, that's pretty intense. So yeah, that's almost a more realistic way of how a specular light would behave, but it is through these values, like setting them up like this. So if you use that, if you put them like that, then that's what you will get, where you will get the part that is lit being blue and then the rest of it being white. Okay, so that's the specular right there for you. And so another cool thing that you can do with it is that if you wanted to give it like a more three-dimensional look, then you could do that using a blur filter. Okay, so now what we're gonna do is we're gonna add a Gaussian blur, okay, just to see another interesting effect that we can get out of it. So just want to also give it more like a three-dimensional feel where the shape almost looks like a 2.5D surface, you know, with some volume. So create that quickly. So it's Gaussian blur, and for n value we're gonna use the source alpha. What the source alpha means, the alpha of the shape on which we're going to be applying this effect. Okay, so and then we say standard deviation, and then we say standard deviation will be equal to 9, and we say results. Then we're going to call the results blur. Okay, and then we're going to close this guy. And now what we're going to do is then we're going to composite this. So we say FE composite, we'll say N is equal to spec light. Okay, and then we say N2. We'll say N will be equal to source. We're going to use the source alpha, and we'll say operator. And then for the operator, we're going to use N, and then the result thereof will be called spec light. We're just going to override spec light. Okay. And so let's close this guy down. And here, okay, first of all, let's have a look at our rect. Let's see what that looks like. So basically all that's happened, it's even more white, it's almost invisible here. But in order to see the effect of what we created with everything that I've explained in terms of how these values work, what we're going to do, then we're going to make that 0, turn that into 1, and then we turn also that into 1. And so this is the effect that we have. So you see now our light is hitting this area. Now maybe I can just bring it in a little bit more. Let's make that okay. So now but now you can see a little bit of, it's almost like a bevel now. So that's what the effect looks like. It's almost like a bevel. But in order to illustrate this better, what we're gonna do is we're gonna then change the surface scale. So I'll say 0.75, and then I'll say the surface scale will be 2.5. Okay, so now this is what we get. So with the surface scale, so it just means that the surface is moving also a lot closer, but that becomes also more visible. See, so now we've got that little creation over here, but that looks pretty cool. So I can also still increase the size of and how the light spreads. So now it's spreading more, but you still kind of have that almost bevel-like effect, and you can still move the light in a little bit more. So okay, but that was not so obvious. Let's see. Okay, so there's our light there. Now if I want, I can make the specular constant bigger. I'll say 2. Ooh, that's pretty intense. I'll say 1. Okay, so that's what we get. You can get the idea. But now you see you've got this like little cool effect here, which is pretty neat, not bad. So yeah, so this is this is where the light is hitting, and yeah, you can see the kind of effect that we're getting from it there. We can also maybe move the light also a little bit to that side, so now it's kind of hitting it from the side, and then we'll say 200. You know, so this is the kind of effect that you can get. Turn it back to 50. So hey, you know, you can just kind of really play around with this stuff and see what else you can do. Then we can move it also a bit out, and then it covers more of the surface. But yeah, so this is the kind of effect that you can create, and then we did this all by using the alpha, the Gaussian blur. and then we used the source alpha, so it's basically taken the shape which would be black. So this is the effect that we get, and this is because of this over here, this Gaussian blur. This is what's helping us to get this kind of effect over here. Without it, this is what it would look like. Okay. All right. So yeah, this is the lesson for the day. I mean, you can use this with all other types of lights. You could use it with the spotlight, and you can use it with the distant light. So for this example, I just mainly use the point light. So you can just take the other types of lights and just experiment with it. But yes, this is what the specular lighting does. Okay, yeah. So till the next lesson, my brothers and sisters, love and peace. I'm out. If you thought this video was good and helpful, please press that like button. For any questions or input, just remember to leave a comment. And if you want to see more videos like this, then subscribe to my channel and I'll keep more stuff coming your way.